Greetings, welcome back to ATB Mathfocus. Today we'll be focusing on finding missing sides and missing angles on a right angled triangle. Finding missing sides on a right angled triangle. So this time we want to find a missing side given one side and one angle. So we want to find a missing side. So to find a missing side, for instance, here on this diagram, we want to find the missing side, which is B. What we first need to do is to see what items do we have, right? So we have our 41-degree angle here, and obviously this is our right angle because this is a right angled triangle. So we said opposite to this 41-degree angle, we call this side opposite, the opposite. And we said this side that is adjacent to this angle, we call it the adjacent. Having this adjacent, this is obviously our hypotenuse. We have our hypotenuse here. So we have managed to name the sides, right? And now we are looking at what we have. What are we given according to the question? So we are given the hypotenuse. We are not given the hypotenuse, but we want to find the hypotenuse, which is B. We are given the adjacent, which is 13, and we are given our angle 41. So now we want to go back to SOHCAHTOA, to the SOHCAHTOA abbreviation, so that we can see which trigonometrical function can we use for our adjacent and our hypotenuse. So let us write SOHCAHTOA. So here on SOHCAHTOA, we said we want a trigonometrical ratio with a trig function with an adjacent and an hypotenuse. So we have adjacent and hypotenuse on our cosine trigonometry. So on our cosine trig, we write cos theta is equal to the adjacent over our hypotenuse. So now we are moving. So we are saying this time our angle is 41 degrees and adjacent we have 13, and we want to find the hypotenuse B. So we write what we have. Cos 41 is equal to adjacent, we have 13, over our hypotenuse B, the one that we want to find. So now the math has been made easier. So we are just going to make B subject to a formula so that we can find the value of B. So we cross multiply here. This is obviously over 1. So we say 13 multiplied by 1 and B multiplied by cos 41. So we say B times cos 41 is equal to 13 multiplied by 1, which is just 13. So now we are saying B cos 41 is equal to 13. So to find B, we divide both sides by cos 41. So divide by cos 41 over cos 41. So we say cos 41 into cos 41, we get our 1. Then 13 over cos 41, we have to punch this on a calculator and make sure your calculator is in the degree mode. So we say B is equal to, we go to our calculator, we say 13 over cos 41. We have 17,2. So this is the value of our B, which is the side, hypotenuse side is 17,2. So you can replay the video, you pause the video, you work it out, and you see whether you've got it correct. Moving on to our example 2. So for example 2, we are given this side, which is y, the unknown variable or the unknown side. So we want to find the value of y. Given this side, which is 10, and our angle 37 degrees. So the first thing first, we name the sides of this triangle. So opposite to this 37 degrees, we have our opposite. And obviously this opposite to the 90-degree angle, or this longest side, is our hypotenuse, which we are not given and we are not worried about on this question. And we have this side which is adjacent to the angle. We call it the adjacent. So now that we have named the sides of the triangle, we want to move to the next step, where we are to look at the sides that we are given in relation to the angle and try to relate it to the SOHCAHTOA abbreviation. So now we are saying we have the opposite and the adjacent. We want to find the opposite and we are given the adjacent. So we write our SOHCAHTOA. So this time on SOHCAHTOA, we want the opposite and the adjacent. The opposite and the adjacent. We have opposite, adjacent with our trig function tan. So we are saying tan theta, we are going to use tan theta is equal to the opposite over our adjacent. Now that we have tan theta is equal to the opposite over our adjacent, our tan theta is equal to opposite over adjacent. So now for theta, we are going to write 37. So it's tan 37 is equal to the opposite over adjacent. And now we want to put in our values. Tan 37 is equal to the opposite, we said it's y, our unknown variable, over our adjacent 10. So now we want to make y subject to formula. So this time it's easier. We are just going to multiply. We are just going to multiply both sides by 10, or we cross multiply. You choose what to do. So let us cross multiply. Is over 1. So we are saying 10 tan 37. 10 tan 37 is like 10 times tan 37 is equal to y times 1, which is just y. So we have 10 tan 37 is equal to our y. So now to find the value of y, we say 10 tan 37 in degree mode on our calculator, and we get 7,5 is equal to y. This is our value for y. So we have our side y, which is 7,5. So for our 7,5, I have rounded. The initial value that I got was 7,535540501. So I've just decided to round it to one decimal place. So it becomes 7,5. So this is the concept. Our y is 7,5. Let us move on to our third question, third example. So we are saying this time we are given this hypotenuse, the longest side, to be 12. We have our side with x and our angle 34 degrees. And we are told to find the value of x, which is our, all right, we are yet to find, to know which side is it, right? So let us go to the first step. We are going to name the sides of the triangle. So this time we have this side, which is opposite to the angle 34 degrees. So this is our opposite, and we have our longest side, which is our hypotenuse. We have our adjacent side, which is the adjacent. So now, so we are given the hypotenuse, and we want to find the opposite given angle 34 degrees. So we come for our working, go to our working, right, where we are going to write, first write SOHCAHTOA. You should master this. SOHCAHTOA. So on SOHCAHTOA this time we want a trig function that have got opposite and hypotenuse. So opposite and hypotenuse, we have our sine. Our sine theta sine of angle theta is equals to the opposite over hypotenuse. So now we are saying this time our angle is 34 degrees. So we are saying sine of 34 degrees is equal to opposite x over hypotenuse 12. So we are saying x over 12. This time we want to find the value of x. So we are just going to cross multiply, or to multiply both sides by 12. So let's cross multiply. So our x, we can say x times 1 is equal to 12 multiplied by sine 34. Right? So we are saying our x is equal to 12 times sine 34 degrees. We punch this on our calculator on degree mode. So we are going to say 12 times sine 34. We get 6,7103148. So we are just going to round it to one decimal place. Let me write here the value. It's 6,7103148. So we want to round to one decimal place. So we look at this one. I know you are able to round to one decimal place. So it becomes 6,7. And remember, this 12 was in centimeters. So also our 6,7 should be in centimeters. This is the value of x, which is our opposite. So you can pause the video and do likewise. This time we want to find missing angles. So we can look at our triangle here. So having this triangle, we have our missing angle, an unknown angle theta, and we want to find this angle theta given two sides. So we are given this side, which is 8, this side, which is 17, and we already know that this side, the longest side, is our hypotenuse. This is our hypotenuse. And now we want to know which side is this. 8 is representing which side. So according to our reference angle theta, the side which is opposite to theta is opposite. So we are given the opposite and a hypotenuse. We want to find the value of theta. We go back to SOHCAHTOA. Sorry, we have SOHCAHTOA. So on our SOHCAHTOA, we want to find the trig. We are looking for the trig that have got an opposite and a hypotenuse on its formula. So we are saying an opposite and hypotenuse is, the trig function is sine. So we are saying sine of our angle theta is equal to the opposite over hypotenuse. So now we are moving on. Our sine theta this time is equal to our opposite we have, which is 8, over our hypotenuse we have, which is 17. So now we want to find our angle theta. So to find our angle theta, we have to remove the sine which is attached to theta. Removing this sine, we introduce what we call arc sine or inverse sine. We do it both sides. So when we introduce the inverse sine of sine theta, we get theta. And now the inverse sine of 8 over 17, you get it from a calculator. So we are saying theta is equal to the inverse sine or the arc sine of 8 over 17. This is called the arc sine. So arc sine, we go to our calculator, make sure it is in degree mode. We say arc sine of 8 over 17. The arc sine of 8 over 17 from a calculator is 28. It says theta is equal to 28 0.072486936, like this from the calculator. So now we want to round it to one decimal place. So our theta is equal to 28.1 degrees, because our angle is in degrees, right? It's not 34, I'm sorry. Our angle theta is in degrees, so 28.1 degrees. Moving to our next equation, question 2. So this time we are given a hypotenuse which is 13, and this side which is 4, our unknown angle theta, which is our angle of reference. So we want to find the value of theta. So likewise, we do the first step where we are going to name the sides of this triangle. So we said this is the longest side, which is the hypotenuse, and opposite to this theta is our opposite, and this is obviously our adjacent. So this time we are given a hypotenuse and an adjacent side. So given these sides, we go back to SOHCAHTOA so that we can see what do we have. According to the adjacent and the hypotenuse, we are going to take which trigonometrical function. So this is SOHCAHTOA. All right, so we having the SOHCAHTOA, we can say we have our hypotenuse and our adjacent. So this is obviously cos. Adjacent and hypotenuse, cosine. So we are taking this trigonometrical ratio. So we are saying cosine of theta is equal to the adjacent over the hypotenuse. So now that we have the adjacent over the hypotenuse, we are going to write cosine of theta is equal to the adjacent for hypotenuse 13. So we are saying 4 over 13, and we do like what we did in the last equation, where we are going to introduce arc cos. This time it's arc cosine of theta. So we are saying arc cosine here, arc cosine of cos theta, we get theta is equal to the arc cosine of 4 over 13. Arc cos or inverse cos of 4 over 13. We go to our calculator and we punch this so that we get the value of theta. So our arc cos of 4 over 13, we get theta is equal to 72,079786861, right? So we are just going to round this 72,079 into one decimal place. So it becomes 72.1 degrees. So this is our answer for our angle theta. This is our answer for our angle theta. Moving to our third question. This time I want you to pause the video. You try to attempt this question to find the angle theta, and then you play the video so that you can see whether you got it correct. So this time we are given this side 5, this side 12, our angle theta, and we want to find our angle theta. We are not given the hypotenuse, so we don't need the hypotenuse to solve this question. So now we are given the opposite to this angle theta, which is 5, our opposite, and obviously this is our adjacent. So now that we know that we have the opposite and the adjacent, the trig function obviously is tan. I can just write the SOHCAHTOA. And from the SOHCAHTOA we know that we have our opposite and adjacent. Opposite and adjacent here, the relationship is on the tangent ratio. So we are saying tan theta is equal to the opposite over our adjacent. So now our tan theta is equal to, the opposite we said is 5, our adjacent is 12. So we're saying 5 over 12. We introduce arctan of theta, so it's arctan of tan theta, we get theta is equal to, here, the arctan inverse tan of 5 over 12, so that we can get the value of theta. So theta is equal to, so if you go to our calculator and you write arctan of 5 over 12, we get 22,619864948. So we want to round to 1 decimal place. So to 1 decimal place, it becomes 22,6 degrees. So this is the value of our theta. So now that we have done all the 3 questions, you can try to find other questions to attempt. And if you still get a problem, you can come to my inbox or you can comment in the comment section so that we can help each other. Thank you for watching. I hope you learned something from the video. See you on the next lesson. We'll be looking at the sine rule and the cosine rule.